Very good morning. As in our previous sessions, we have seen what are all the elements of communication system. In today's session, we will discuss about signal, types of signals. As I said earlier, signal is a physical quantity which varies with respect to time or space, or it may depend upon independent or independent variables. Coming to the representation of signal, we can represent in this way. Normally, we will represent it as x of t, y of t, z of t. It's our choice. So here I am representing with m of t equals to, I am taking a cosine signal. If you take either cosine or sine wave, you know that you will be having an amplitude, frequency and phase. So we are representing here a signal as m of t equals to a cos omega t plus phi. Here a represents the amplitude of the signal, omega represents the angular frequency, which is radians per second, and phi represents the phase of the signal. So this is what is meant by signal and representation of signal. If we see the types of signals, we have two types of signals. Here we are discussing analog signal or digital signal. We can call analog signal as continuous signal also. Why? Because if you see here, the analog signal is defined as the signal where the amplitude, you can observe here in this figure, this is amplitude which we are representing here on x-axis, sorry, on y-axis. On x-axis, we will be representing our frequency. So where the amplitude is continuously varying, means at 0 it is 0, 0.1 some value, 0.2 another value, 0.2 like that. So here the amplitude of the signal continuously varies with respect to the time period t. If the signal contains infinite number of amplitudes, then we can call it as analog signal, as we can call it as continuous time signal also, where the amplitude is varying continuously with respect to the time period t. You can observe here clearly by this figure where the amplitude is varying. Then coming to other type of signal, that is digital signal. Digital signal have only two values, like either it may be high or either it may be low. It will consist of only two discrete amplitudes, so that we will call it as a digital signal. But coming to our communication signal, we'll be having baseband signal and bandpass signal. In the name itself, you can see baseband. When we will call it as baseband signal means, if the signal contains zero frequency, it is called as baseband signal. Either 0 or nearer to 0. Means very low frequency signals, I can say. Yeah, for example, you can take it as biomedical signals, video, audio, voice. All these are baseband signals. If you want to transmit these baseband signals, we need to go for the process of modulation, where converting our low frequency signal into high frequency signal. In next sessions in detail, we will see those things. Next, coming to band pass signal, if the signal contains band of frequencies other than 0, it is called band pass signal. We can call them examples like AM signals, FM signals. That we will see what is meant by AM, amplitude modulation and frequency modulation. So here we need to learn some of the basic things like message information, as in the previous sessions also we have seen. So message is, it is a sequence of symbols. Like here you can write Happy New Year, we have given. So like that. Information means it is the content in the message. If there is an information, then we will call it, some content should be available. So we will call it as an information. Information is measured in bits, digits, and nats. As we are discussing about communication systems, we have some limitations of communication systems like bandwidth and noise, technological problems, and signal to noise ratio. Technological problems means to transmit our information that communication systems to implement, we need our transmitters and receivers chart, which requires some hardware components. Depending upon the technique, those transmitters and receivers may be expensive, and for designing, they may be complex. So that is one of the limitation. Bandwidth and noise, where we are transmitting our information through the channel, either it is wired or wireless, definitely there will be noise will be affected. So we can reduce our noise by providing more bandwidth. But due to this, less number of stations can only be accommodated. Why? Because more bandwidth we are giving to the stations. Signal to noise ratio. We all know that noise should be very low to increase channel capacity. But in communication system, noise is an unavoidable aspect of communication system. In our next sessions, we will discuss about our modulation. Thank you for this.